speaking of Fabian, we have Fabian with the talk about with config.
Does it work? Okay, it does. Yeah, let's get over to something completely different. This is with config.bazel. If you want to know how hard it is to rename things, look at the agenda for today. It's still called with config, so that was troublesome. This is about making transitions more accessible and also making their use more responsible by lowering their footprint. I'll start out with some concrete example that will guide us through this talk. So let's, okay, this doesn't work, whatever. So this is a general, like simplistic synthetic build setup where you have a CC test that has some code generation via again rule and has some data dependency and some other binary, some deps, and then there's also a Go binary that also depends on some, in the end, common base library that both of these targets transitively depend on. And now let's say you want to instrument your test and all its dependencies with a certain compiler option. Because I have a background in fuzzing, this will be address sanitizer, which is a tool that sort of you can use to instrument your tests and code to catch memory issues at runtime. How do you do that? Well, there are different ways. You can say, okay, I'll just set a copt of something. The concrete value doesn't matter here. When you do that, and you still want your developers to be able to just build everything, which is the simplest thing to do, this copt will leak to, for example, the CC library that's only used by the Go binary, which is not something you want, because maybe the Go binary can't even deal with this kind of instrumentation. So that's not so good. What can you do? You can tell your developers that, well, if you want to use this flag, please only build these particular targets, and then, I don't know, you maintain a Confluence page for that. But that's horrible. Like, nobody wants to remember these flags and sets of targets. So you can get fancy. You can use transitions, which is a Bazel feature that essentially allows you to change settings for a target and all its dependencies, but to have that be isolated from all other usages of this dependency. Of course, that works, but that leads to certain things being built twice. So for example, that CC library, that's a common dependency, that will be built twice, which is necessary and okay. But then, for example, your general will run twice, potentially. Also, this still leaks to the data dependency. Do you want that to be instrumented? Probably not. So this is very leaky. You can do it, it works, it's correct, but it may increase your build times. So the idea is that we can have something more targeted. We have something that sort of removes the boilerplate, that allows you to easily wrap an existing rule with transitions, and gives you full control over the spread of these transitions. And that's where this Starlark library with config.bazel comes in. And the idea is that you get a flagless build where you just can do Bazel build everything, and the right flags are used in the right places. So yeah, it's a Starlark library. You can use your favorite rule as a base, and then tweak some Bazel settings for it. For example, have a Java library that always builds for Java 21 and resolves the correct toolchains for that. Or in file group that always builds everything with compilation mode opt if you want faster integration tests. And you can also configure automatically or manually if you need more control the way that this transition spreads to the individual attributes. So you can handle depths differently from, say, sources. And this supports Bazel 6.4 and later. So let's look at a concrete example. So this is essentially what we just looked at, just a bit more concretely. We will make a version of CC test that builds everything with address sanitizer. So what we do is we load essentially the single symbol provided by this library with config, and that gives us a builder. It's a bit uncommon for Python, but I think that it could work pretty well here. So we apply the with config function to the existing CC test rule. Because this is in a Bazel file, we need to use native.cctest to see that symbol. And then we can call the extend or set method. So there's a set method for modifying a setting, and the extend method for modifying a list-based setting, so for sort of appending compiler options instead of replacing all the ones that are there. And here, for example, we just append fsanitize address to the compiler options and the linker options. Then we call builder.build, and it spits out a new rule that we can use. This isn't exactly everything. There's one, well, Bazel restriction. There is an internal rule that this uses, and for some reason, I mean, for a good reason, but for a reason that's a bit annoying here, you need to assign this to some top-level variable in your .bazel file. but the name doesn't matter and you don't have to use it. So if you just, this is sort of the boilerplate that you need to make this work. And it also supports selects. So if your values are a bit more complicated, if you say, okay, here, for example, on Windows, the linker complains about this flag and it doesn't need it. So you can actually hide that complexity in this new CC async test rule by using a select. That just works with all the existing Bazel configurability features. And now for the fun part, you can also say, I don't want this change of settings for certain attributes. So for example, you probably don't want async to leak to your source generation. And that's why you can also call this reset on adders function, provide a list of attributes that you don't want to apply this change of settings to. And then, well, it will magically reset everything. And you also get, instead of this useless underscore rule that we had on the previous slide, you get a rule with which you can manually reset certain dependencies. For example, in your Java 21 library, maybe some target builds only with Java 7. I hope that's not the case for you, but reality says that this can happen. In that case, you can just wrap that target in this rule, and it will build with Java 7 just fine. And there's one target, this CC async test original settings. That's sort of a central place where your original settings are stored. That's just a target that you need to declare in some build file once and then forget about it. So in the end, you can use CC async test, and then you sort of get exactly the shape of the build graph that you want, and everything works with Bazel build // ... Yeah, thank you. This is how you can use this with Bazel mod, and the repo you can check out.